Good afternoon, everyone. This is the relearning video for our second standard this year, identifying features of a graph. You should have the worksheet out in front of you that I gave you in class, the relearning paper. First of all, the parts of a graph include the title. I think most of us know what this is. The big difference for a title in a graph is that it is not going to be, it's not like when you write an English paper and you want to have a catch phrase, something that gets the reader interested. It's going to be more explanatory. X-axis, just like in math, is this bottom axis down here. It's the horizontal axis of the graph, and then the one that goes up and down, the vertical axis, is the y-axis. The scale is going to be what each box equals. Now this was a more difficult concept for us on the test, so we'll talk about that in a minute. And then what is the unit of measurement? So is the x-axis talking about time in seconds, minutes, hours, days, years? It's important to include units with that. So let's look at an example. So the example here would be in this graph, the title is temperature change. I just got this off the internet. Nothing too exciting about this graph. On the x-axis, the label is time, and then each box here has a scale of 3 hours. All right, if you look at what's happening between the numbers, it's evenly spaced and it's of 3 hours. Now, one thing interesting about this graph is the y-axis starts at 0, but the x-axis is not. That's because the difference between the zero time or midnight and 5 a.m. is not 3 hours. And so it's okay in this case when we're tracking temperature change over a specific amount of time to start it at 5 o'clock a.m. The unit, while it's not labeled, is clearly hours. The y-axis label is temperature. The scale on the y-axis is 1 box equals 10 degrees. We can see that each box is labeled and increases by 10 degrees. And the units in this case is degrees Fahrenheit. Units typically are written out in parentheses. Independent variable is going to be independent. It does not depend on anything else. And it's something that is not affected by whatever else you're measuring. So things that are not affected by something else you're measuring are typically things like time, the years, the age, and we always put this on the horizontal axis, which is again the x-axis. The dependent variable, what depends on the other, and it's also what's being measured, goes on the y-axis. Some examples of this that we saw in our class and on the test would be distance, or the number of cell phones that teenagers used, depending on how old they were. We were fine with the types of graphs being used, but the thing that we got stuck on was why they were being used. A bar graph compares certain numbers, but line graphs use to express change over time. And I'll show you what is really helpful about a line graph in just a moment. So if we look at this graph, it's not a scatter plot graph. There's not just dots on it. There is actually lines drawn between it. And the thing that is helpful about the fact that there are lines drawn is that we can say, if I was to ask you how many people are in the store at 12:30, well, you could give a rough guesstimate of that, okay? We wouldn't know exactly. We don't have a data point for that, but we can guess that with quite a bit of certainty that at 12:30, halfway between 12 and 1 o'clock, we're going to go to 12 and 1 on our x-axis because that's our time that we know, and they're going to go up the graph until 12:30 runs in to our line. And so here I am. This is where my line graph crosses the point of 12:30, and I'm going to see, okay, now where, I lost my cursor, excuse me. Where is that? So it's on this gray line, so I'm going to follow it to the y-axis. Well, it's above 15 and below 20. Let's see what our scale is here. Our scale is, our scale appears to be 1 person for every line. So 1 more than 15 is 16. So at 12:30, there appears to have been, it's likely there would have been about 16 people in the store. Again, we don't know that for sure, but this is something we can suggest is likely. Going to the next one, when we make a graph, we want to make sure that the graph has all of these things. So it has title, has axis labels, has units, and evenly spaced numbers. So we're going to go, I'm going to open up my projector, All right, and we're back. So I'm going to go ahead and create my graph. I'm looking at my graph. I need to figure out what is going to be the title. So please go ahead and make this graph with me. I'm going to try to get my little box to go away here. Okay. So the title, this title is Miss McConnell driving in town. And time is always going to be, when we're doing a time distance graph, time is our independent variable, so we're going to label time, and it's given me my unit, so I'm going to put down unit, time in minutes, and distance in kilometers. Some of you put the labels but didn't put the units down. It's important to do both. Then we need to go ahead and we have our title, our axis labels, our units. We need to evenly space our numbers. Now, this, if I count it up, this graph has 20 boxes both up and across. And so my highest number is 20 for both of them. So I'm going to go ahead and label each box. Now, one thing that a lot of people did was they evenly spaced everything except for this first box. This first box has to still be properly spaced, okay? If for all the rest of the boxes equal 2, you can't make the first one equal 1. Or if the rest of them equal 1, this one can't equal 2. Especially when you have your first data point being 0, 0. So you should be making your graph along with me. This is a very important skill, whether you're in science or in math, or when you're in your job in the future. Typically your graphs won't be made by hand, but you have to understand the important parts of the graph. Otherwise, you might make a graph when you're trying to convince your boss of something, and if you make your graph wrong and he realizes that or she realizes that, you may have just totally ruined your whole point. Okay. The next thing we have to do is make sure whenever we graph that we go to the x-axis for our time and the y for our distance. Now, if you got these mixed up on the test, that is partly my fault. And the reason that's partly my fault is in one of the practices we did, I listed distance on the top and time on the bottom. And so I think when people were going through and graphing, they got them flipped in their heads. So please make sure that you're graphing time as the x-coordinate and distance as the y. Otherwise, your graph's not telling the correct story. Another thing people did was they forgot to put this first data point in. So make sure you get your first data point. Then we're going to go to 5 and 2. Then we're going to go 8 and 10. We're going to go to 12 and 16, 15 and 20, and 20 and 13. Okay, so hopefully you didn't get any of your x and y's flipped, so make sure that you have that correct. Next and last, you want to go ahead and connect your dots. And what this is helpful for is if I was to ask you how far away from home, assuming that 0 is home, was I 3 minutes after school, well, you would say, well, you're about 1.5 kilometers away. Or I can say, well, about 10 minutes after school, go to the 10 minute and follow it up until the graph crosses 10 minutes, you're approximately a little more than 13 kilometers away from school at that point. So the lines, by connecting the lines, we can make those assumptions. I hope this was helpful. Please let me know if you have any questions. There are some more practice problems on the worksheet, so please go ahead and complete those and return the worksheet to me. I'll check your work, give you any hints you need, any help you need, and you should be good to go. Thanks very much.